Hi, good morning to one and all. In previous class, we discussed about and types of rolling, that is hot rolling and cold rolling. Okay, in this session, we discussed about classification of rolling mills, roll passes, okay, and nomenclature of roll products. Okay, first we'll go through the nomenclature of roll products. By understanding this, we can use to understand the what we are doing by using the rolling process. Okay, first coming to blooms, it is the first product obtained from the breakdown of ingots. A bloom has a cross section that is ranging in size from 150 mm square to 250 mm square. In some times, that is it will 250 into 300 rectangle. Okay, like that we have to prepare the blooms from the ingots, that is we are reducing the cross section by using the rolling process. Okay, the ingots is mainly cut into blooms. Okay, like that the size we have to preparing. Here the ingots are prepared from the by using the steel making industries, by using the iron ore. Okay, by that we are getting the raw material to the metal forming process, that is known as from the primary manufacturing process we are getting the raw material. Okay, next coming to billet. A billet is the next product rolled from a bloom. Billet vary from 50 mm square to 125 mm square. Observed here the size is reduced, that is 50. The square the range from 50 mm to 125 mm will be varies. That is, by using this roller process, the blooms can be converted into billets. Okay, based on the requirement of size, we have to select the roller size. Okay, by using that rolling process, we are converting from blooms to billets. Next, coming to slab. Slab is a rectangular cross section with thickness, that is ranging from 50 to 150 mm, and is available in the lengths up to 112 meters. Okay, the maximum length is 112 meters. Based on the dimensions, that is the slab is 50 to 150 mm thickness. Okay, the thickness is 50 to 150 mm and the length is maximum up to 112. Okay, based on this we have to prepare the slab by using the rolling process, is termed as slab. Next, plate. A plate is generally 5 mm or thickness is 1 or 1 point thickness and 1 to 1.25 meters in length, that is and 2.5 meters in length, and width is 1.5 1.25 meters. Okay, these are the dimensions of the plate. We have considered that part is known as plate, that is the thickness is 5 and 1 to 1.25 meters in width and 2.5 meters in length. Based on the dimensions, it is known as plate. Next, for coming to sheet, a sheet is up to 4 mm thickness. Okay, here the thickness is 4 mm, that is maximum. Okay, and is available in same width and length as a plate, but the main difference is thickness, that is the sheet is up to 4 mm thickness, but as in case of plate it is 5 mm, that is minimum thickness is 5. Next, coming to flat. Flats are available in various thickness and width and are long strips of materials of specified cross section, is considered as flat. Next, foil. It is a very thin sheet, it considered as foil. Next, coming to bar. The bars are usually of circular cross section and of several meters length. Okay, there is no specific dimension, but it is in circular cross section. They are common stock, that is raw material for caption and turret lathe. Based on this, basing the lathe, we have to prepare the products basing the lathe machine. That is, the raw material is bar. Next, coming to wire. A wire is a length that is of a small round section, the diameter of the which specifies the size of the wire. Okay. Next, coming to types of rolling mills. Okay, in previous section we discussed what is rolling process and types of rolling process. Coming to rolling mill, what is rolling mill? A rolling mill is nothing but wherever we are decreasing the cross section of the workpiece from higher to lower, that is known as working mill. Okay, sorry, rolling mill. The rolling mill may be classified according to the number and arrangement of the rolls. Based on this, we are classified. That is 2 high rolling mill, 3 high rolling mill, 4 high rolling mill, tandem rolling mills, cluster rolling mills. Okay, these are the different types of rolling mills based on the arrangement and number of rollers. Okay, coming to 2 high rolling mills. 2 high rolling mills may be further classified into reversing mill and non-reversing mill. Okay, here main one difference is in between the reversing mill and non-reversing mill, except the remaining all things are same in both cases. Okay, a 2 high rolling mill has 2 rolls only. Okay, coming to 2 high reversing mill. In 2 high reversing mill, the rolls rotate in one direction and then in the other direction so that is the 2 rollers are rotate in opposite direction. In that way, the workpiece will move to forward, so that the rolled metal may pass back and forth through the rolls in several times by using this 2 high reversing mill. Next, this type is used in plumbing and slabbing mills and for roughing work in plate, rail, structural and other mills we are using 2 high reversing mill. Okay. Next, these are more expensive compared to the non-reversing rolling mill because we are using a separate setup for rotating the reverse direction. Okay. Next, because the reversible drive is needed, for that the cost will be increased. Okay, observed in this diagram, here it is the upper roller and it is the bottom roller. It will rotate in anti-clockwise direction and it will rotate in clockwise direction, here applying direct compressive forces on the material as discussed in first class. Next, here it is the material and it is the grain structure of the material before rolling process. It will very coarse in size. Next, whenever we pass the workpiece in between the 2 rollers, what happened here? The cross section will be reduced and the grain size will be reduced and refining of grows and forming of new grains in the material is known as recrystallization. Next, here like that we are pass the workpiece in between the 2 rollers. Again in the same way, we are again sending this workpiece in this direction, like that in the time it will rotate reverse to the indication arrows, like that the work process can be carried. Okay. Next, coming to 2 high non-reversing mill. In this 2 high non-reversing mills as 2 rolls which revolve continuously in same direction, therefore smaller and less costly motive power can be used as in case of reversing mill. Next, however, every time material is to be carried back over the top of the mill for again passing in through the rolling. Okay, it is the main disadvantage in the non-reversing mill, because every time we have to collect the material from the finishing process, again it will transfer to the starting point. Okay, it will be some time consumption. We have to require extra labor or equipment to carry the work part from finishing area to the end starting area. Okay, such arrangement is used in mills through which the bar passes once and it open train plate mill. Okay, like that in that area where we use non-reversing mill. Okay, next coming to two high non-reversing mill. Okay, it is a diagrammatic representation of non-reversing mill. Here the workpiece will pause in between the two rollers. Again, we cannot pause into the in this direction. We have to get the workpiece and will flow get into the again starting point. Like that, we have to reduce the workpiece. It is mainly used where we need and one pass. We will use the two high non-reversing mill. Okay. Next coming to three high rolling mill. Okay, here it consists of a roll stand with three parallel rolls, one above the other. Okay, it consists of mainly three rolling mill. Next, three rolls. Next, adjacent rolls rotate in opposite direction. Okay, two adjacent rolls will be rotate in opposite direction. Suppose it mainly consists as three rolls. Suppose first two rolls will rotate in opposite direction. Same in case of two high rolling mill. Okay, and coming to bottom two, it will rotate in opposite direction to the first two. Okay, like that the arrangement is constructed so that the material may be passed between the top and the middle roll in one direction. Okay, and the bottom and middle roll in opposite one. Like that the arrangement will be done. Okay, in three high rolling mills the workpiece is rolled on the both forward and return passes. Like that we have to use. Next, first of all, the workpieces to the bottom and the bottom and middle rows, and the returning between the middle and top rows. Like that, the arrangement will be carried so that the thickness is reduced at each pass. Okay. Next, mechanically operated lifted tables are used which move vertically or either side of the stand. Okay. Observed in this diagram. Here the work piece will flow in this direction. What happened here? It will rotate in clockwise and it will rotate in anti-clockwise. For that case, during the first rotation, what happened? It will reverse in opposite direction. Like that, the workpiece will move in this direction. Okay, and again in this direction. Like that, the rolling process will be done in three high rolling process mill. Okay. Next, so that the workpiece fed automatically into the roll gap. Okay. Next, since the rolls run in one direction only, a much less power motor transmission system is required to run the three high rolling mill. Okay, as compared to the two high rolling mill. Next, the rolls of three high rolling mills may be either plain or grooved to produce plate or section respectively. Okay, coming to four high rolling mill. In this, it has a roll stand with four parallel rolls, one above the other. Okay, the top and bottom rows rotate in opposite direction as to the middle rolls. Next, the two middle rollers are smaller in size than the top and bottom of the rolls, which are called the backup rolls, for providing necessary rigidity to the smaller rolls. During the hot material, some amount of forces will be developed on the working rolls. Due to this, the rolling process cannot done accurately. For that case, we are using a backup rolls. It will hold the it supports the working roll. Next, a four high rolling mill is used for hot rolling of armor and other plates, as well as cold rolling of plates, sheets and strips. In that way, we are using four high rolling mill. Okay, observed here. These two rollers are known as work rolls, and these two rolls are known as backup rolls. Here, observed whenever the work roll is rotating clockwise anti-clockwise direction, anti-clockwise direction, it will rotate in same direction. Sorry, here it will rotate in clockwise direction. Here given mistake. In the same way, here whenever here rotates in clockwise, it will rotate in anti-clockwise direction. The work material will pass in this direction between the two work rolls. Okay, like that the process should be carried. Here whenever we process the rolling process of hard materials, due to this what happened, a high amount of forces will be developed on the work rolls. For to reduce these, we are using a backup rolls, that is it will support the work rolls. Okay, like that we arrange in 4 high rolling mill process. Next, coming to next classification, that is tandem rolling mills. It is set of 2 or 3 stands of rolls set in parallel alignment. Okay, like that we have to arrange rollers one another, so that a continuous pass may be made through each of one successfully with change the direction of material. Okay, observe here we are place, that is 4 high rolling mills in a sequence, that is in a parallel way. Like that whenever the cross section of the material is continuously decrease in number of passes in continuously. Okay, we are reducing the cross section of the mills based on the requirement of shape. The rolls, the working rolls size and shape will be changed. Okay, it will support the backup rolls. Okay, is known as tandem rolling mills. Okay, next coming to cluster rolling mills. Here it is a shape special type of 4 high rolling mills in which the 2 working rolls is backed by 2 or more of the larger backup rolls. Okay, for rolling hard in materials, we are using cluster rolling mills. It may be necessary to employ work rolls of a very small diameter but of constant length. Okay, next, in such cases, adequate of the working rolls can be obtained by using the cluster rolling mills. Observe here, it is these are 2 different backup rolls. It is the work rolls. Okay, we will pass the work material like in this direction. In the same way, it is the main difference between the 4 high rolling mills and cluster rolling mills, in that we are using only one set of backup rolls, but in case of two from top and 2 from bottom, backup rolls are used for getting the more rigidity forces from the work rolls. Like that we have arranged in cluster rolling mills. Next, coming to other types of rolling mills, that is thread rolling. Okay, thread rolling is nothing but it is used to prepare threads on the workpiece. For that case, we are using thread rolling, that is deformation process used to form threads on cylindrical parts by rolling them between the 2 dies. Okay, we will make the threads, that is it is an important commercial process for mass producing of bolts, screws performed by cold working in thread rolling machines. By using this, we can make threads easily. Okay, observed in this diagram, here it consists of fixed die and moving die. It will the moving die will move in forward and backward. Okay, in between these two dies, we have to place the workpiece, that is starting blank, that is without threading, that is it is in plane in the surface of the starting blank. It is placed in between the 2 dies. What happened, whenever the moving die it move in forward, what happened, the thread will be formed in between formed on the surface of the blank, because the friction between the workpiece and moving die, due to this what happened, the it will roll in between the 2 dies. Due to this, the threads will be happen on the workpiece. After finishing of the cycle, we will get the finishing part like this. Okay, next, coming to advantages over thread cutting. Okay, higher production rate, but it will in normal machining process what happen, it will take more time to prepare the thread. Next, better material utilization, stronger threads and better fatigue resistance due to the work hardening. Okay, these are the advantages over thread cutting. Next, coming to ring rolling, it is another type of rolling process. Here the deformation process in which a thick walled ring of smaller diameter is rolled into a thin walled ring of larger diameter. Observe here, deformation in which thick walled ring of a smaller diameter is small, but thickness is high. Okay, we have reducing the thick wall to the thin wall, and from smaller diameter to larger diameter. Okay, deformation in which a thick walled ring of smaller diameter is rolled into a thin walled ring of a larger diameter. Okay, like that we are making. Next, a thick walled ring is compressed, deformed metal elongates, causing the diameter of the ring will be to be enlarged. Okay. Next, hot working process for large rings and cold working process for smaller rings we have to use. Okay, based on requirement and size we have to select the hot and cold rolling process. Next, the ring rolling is used to reduce the wall thickness and increase the diameter of a ring. Okay, the thickness of the wall will be reducing, and at the same time we are increasing the diameter of the ring. Okay, by using the ring rolling process. Observed here diagram, it consists of the brown color indicates the workpiece, that is known as a ring. It consists of idler roller and feed. It is the main roll. In between we pass the metal strip, that is higher thickness. By rolling in between number of times, what happened, the thickness of the ring will be reduced, at the same time diameter will be increased. Observed in second process, what happened here, diameter will be increasing and at the same time the thickness will be reducing. These are the edging rollers. We have to prepare the edge, because during the rolling process what happened here, the compressive forces applied in the direction, due to this what happened, the length and the width of the rolling mills workpiece will be increased. For that case we have to maintain the required width, we are using the edging rolls. Based on this we have to fix the edge of this size. Okay, like that we have to prepare the rings in the ring rolling process. Next, coming to roll process. Here the final roll products such as plates, flats, sheets, rounds and sections are obtained in a number of processes starting from billet to slab. Up to now we seen there are number of types of rolling mills. In that we cannot prepare from a single pass from starting to the finishing process. For that case we have to pass number of times in the rolling workpiece into the rolling mills, is known as roll passes. Okay. Next, for rolling the the flat product, plain cylindrical rolls are used, but the sections grooved rollers are used. Okay, for flat product we are using plain cylindrical rolls. For sections we are using grooved rolls, are based on the shape of the product we have to prepare the grooved mills. Okay. Next, the type of grooving done is decided by the final section design. Okay, like that we have to select the groove and prepare the grooving process. Next, there are two types of rolling, that is plain and grooved, as shown figure. Next, the rolls used for rolling consists of three parts, that is body, neck and wobbler. Okay. Next, the neck rests in the bearing provided in the stands, and star shaped wobblers are connected to the driving shaft. Next, through a hollow cylinder. Wobbler acts like a safety device and saves the main body of the roll from damaging if too heavy load causes severe stresses. For that case we are use wobbler. Next, the actual rolling operation is performed by the body of the roll. Okay, observed, it is the plain roll and it is the groove roll. Here wobblers are used to support the body and rollers. Okay, it is the plane and it is the groove. Based on the size of the workpiece, we have to select the grooves. The workpiece pass in between the grooves. We have to reduce the diameter of the wire or bar. But in case of flat, we have to make a thick materials into thin materials by passing in between the plane rolls. Like that, the roll process will be carried out. Coming to continuation of roll process, that is, here the rolls are generally made from a special variety of cast iron. Okay, cast steel or forged steel, because it have to done a rolling process. The rolling materials have to having the high hardness. Okay, in that case we have to use these type of materials, that is cast iron, cast steel and forged steel. Okay, next, plain rolls have highly finished hard surface and are used for rolling flats, plates, sheets. Okay, for that case we have to use high surface finish. Next, coming to grooved rollers, have grooves of various shapes cut on the periphery of the rolling surface. Okay, based on that we have to prepare the size of the groove and shape of the groove. Okay, required shape we have to prepare the roll process. Next, one of the required shape of the roll product is sometimes cut in the lower roll and one of the in the upper roll, so that when the rolls are assembled into the stands, what happens, the required shape in full will be produced on the workpiece material once it passes in between groove of upper and lower rollers. Okay, next, however, it should be understood the desired shape of the rolled section is not achieved in a single pass. We have to pass in a number of passes. Okay, the work material has to be rolled again and again through several passes. Of each pass brings the cross section of the material closest to the final shape required. Okay, next, these passes are carefully designed to avoid any rolling defect from keeping the creeping in. During rolling process, some defects will occur. We have to prepare and we have to pass the work part in between the two rollers. Okay, next, rolling is painstaking process, as would be noticed from the scheme of the process I showed figure, for conversion of steel billet into a round bar. Okay, observed in this diagram various process will be happened for converting the square billet, that is cross section will be here high in the first, it will convert from this square into the circular shape, that is the cross section is circular and very smaller in size. By passing this number of passes we will get this shape. Okay, next, coming to classification of roll process, that is, the roll process sequence can be broadly classified into three types, that is breakdown process, roughening process and finishing process. In breakdown process, these are used for reducing the cross sectional area nearer to what is decided. We have to suppose we have to, the cross section will be in 100 mm, we have to reduce to 10 mm. Okay, for that we have to reduce the cross section in number of process. Okay, that is nearer to that area, that is known as breakdown process. This would be in the first in present sequence. We have to reduce the cross section and shape. Next, roughening process. In this process also the cross section gets reduced, but along with it okay, the shape of the roll material comes nearer to the final shape. In a previous diagram we have already seen the cross section is square, the final cross section is circular. We have to change the dimension, shape and size in this roll process. Okay, next, coming to final stage, that is finishing process. These are all final passes which give the required shape of the pass. Okay, follows a leader pass. Okay, Next, the principal breakdown pass sequence are box pass series, diamond square series, oval square series. Okay, these are the different shapes in the during the breakdown pass sequence. Next, coming to applications. Here, the rolling is used to produce components having constant cross section throughout its length. Next, the whole range of rolled product can be divided into following types, that is structural shape of sections, next plates and sheets, okay, next special purpose called rolled products. Like that we have to divide different shapes. Okay, these are the different shapes of the rolled product, that is circular cross section, square, rectangle, hexagonal, L shape and C, I, next a rail shape, next triangle, T. These are the different cross sections of the rolled process we can made by using the rolling process. Okay, thank you. It is about rolling process, that is classification of rolling mills, roll pass. Okay, in next class we will discuss about forces requirement and on the rolls. Okay, to reduce the cross section of the material. Okay, thank you.